Hey everyone, welcome back to the channel. Today we're looking at what is arguably the most exciting shift in the history of artificial intelligence. While the dream of embodied intelligence has lived in robotics labs for decades, 2025 marks a massive convergence point. We are moving past the era where AI was limited to a brain in a box. This isn't just about better digital assistance, it's about AI gaining a physical presence. We are witnessing the moment where reasoning power of foundation models meets the laws of the physical world. In the past, AI and physical systems relied on hand-coded rules. They were mirrors of their specific programming, following explicit instructions written by engineers. Today, we are moving toward neural physics engines. Instead of just guessing pixels through pattern matching, modern world models are learning the underlying causal laws of the world. They aren't just predicting what a video looks like, they are learning to simulate the very physics of the environment they inhabit. A major breakthrough in this evolution is Google DeepMind's Genie 3, released in August 2025. Unlike previous models, Genie 3 utilizes a spatiotemporal transformer that tokenizes reality into 3D patches. This engine operates at 24 FPS at 720p resolution, allowing for a real-time latent dream. When you provide an action token, the model performs a physics inference to predict the next world state. This creates true object permanence, where the world remains mathematically consistent even when the AI isn't looking directly at an object. This brings us to the biggest technical divide in modern AI, the abstract approach versus the generative approach. The generative approach, seen in NVIDIA's Cosmos and Genie 3, uses high-fidelity brute force to ensure visual perfection. These models expend massive computing power to predict every single pixel, creating photorealistic simulations of the physical world. But Meta's V-JEPA 2 takes a different path. It ignores the noise, like leaves blowing in a storm, to focus only on the signal, the mathematical state of the environment. Because it doesn't get bogged down in pixels, V-JEPA 2 can plan actions up to 30 times faster than its pixel-heavy competitors. But in robotics, speed is nothing without precision. The future isn't about one approach winning, it's about how these two brains work together. This is where the philosophies of speed and precision finally converge. To move safely in a human environment, a robot needs more than just a camera. It needs an imagination. This is done through Model Predictive Control, or MPC. Modern robots use an abstract model's intuition as a fast planner, quickly filtering through thousands of possible paths in milliseconds to find a safe route. But for tasks requiring extreme precision, like picking up a needle or handling a fragile object, the robot relies on the high-fidelity physics of generative models. By using MPC to bridge these two worlds, we are building machines that can dream the optimal path in their internal world before they ever take a single step in ours. To power this system, you need massive data and specialized silicon. We're seeing two hardware paths in this race. On one side, you have Google's 7th generation TPU, codenamed Ironwood. Released in late 2025, these chips are custom-built for 3D block math and extreme responsiveness, linking over 9,000 chips into a single liquid-cooled superpod. On the other side is NVIDIA's Blackwell cluster, designed for massive scale. This is the hardware of choice for Tesla, one of the most aggressive users of robotic silicon in the world. Tesla has moved Optimus to an entirely end-to-end neural network. To train this brain, they've deployed the Cortex supercluster at Giga Texas, a facility housing over 100,000 Blackwell and H200 GPUs. This infrastructure allows Tesla to simulate hundreds of years of robot experience in a single day. They're refining the peace common sense that Optimus needs to move from the factory floor and eventually into our homes. The takeaway is clear. True intelligence requires an understanding of the world we inhabit. Industry experts believe that world models like Genie 3 are the key stepping stones toward AGI. By allowing AI to simulate physics and space, we are moving past jagged intelligence and toward a system that can reason, plan, and eventually solve the root node problems of our civilization. The breakthrough didn't come from more words. It came from AI finally understanding the laws of reality. If you found this deep dive helpful, subscribe and hit the bell so you don't miss our next video. Thanks for watching, and I'll see you in the next one.